Uh, our topic today is about integration between CDS and your custom systems. System integrations is a fluid and highly opinionated topic. I know many of you are experts in this field, but I hope that it will be beneficial and an idea starter at least to anyone new to it. Let's get started. So, unlike us, humans, systems should not care about how other systems are built or how they work. The more systems we integrate, the more complex they become because systems can get busy doing their own work. It leaves them no time to keep track of what other systems are sending or requesting from them. This system preference to carelessness, if we can call it that, is best solved by decoupling them. Decoupling systems means loosening the connection between them in a way that they can still communicate with each other, but without a lot of attached strings. This is a basic design pattern for microservices, but it's not exclusive to microservices, and we can benefit from it here. So in this presentation, we will discuss some of many ways this decoupling can be achieved. So organizations that started to use CDS and the related technologies also have other operational systems that may live for many years to come, in which they invested a lot of time and money. In some cases, we just can't ask these organizations to replace the working systems they have with CDS, even if we can. We may offer integrations so that they have better data overall and happier users. It is really cool if you just say, okay, I will build you a CDS and these are my integration contracts. Please respect them or let the teams who are working on your custom systems respect them. And I will respect any contract that your custom systems expose. Another example is big organizations or international organizations that may have multi-tenant deployments due to some maybe regional laws and regulations. They just can't use a single tenant or a single environment for all the regions, but they may be still interested in sharing pieces of data across these environments. Also, the on-premise Dynamics 365 is not dead yet, and normally an on-premise system lives on some kind of internal network that is normally again protected by firewalls, etc. What if this system needs to integrate with the outside services? The solution that we should implement must be scalable and resilient to anticipate future needs and possible downtimes in CDS or in those custom systems. Hopefully less in CDS than the custom systems, but anything can happen. You always need to assume the worst, where your custom systems or CDS may become unavailable for some time, but in the same time, you don't want to lose important communication between these systems. So what we are going through today is a subset of many ideas for integrations. Many other variations and technologies exist that can fulfill the same or similar outcome, and that's due to the abundance of these technologies. The right technology is based on many factors that will decide what you are going to use, such as existing architecture, cost, or skills of the team. We will look at the Azure ServiceBus initially and how to configure it. Then we will look into a powerful yet simple feature of CDS that allows us to communicate with Azure ServiceBus in a supported way. Then we will touch base on Azure functions and why they are needed in our scenarios. After we discuss our integration scenarios, we will go through some demos and code snippets to see how everything works together, loosely yet robustly, hopefully. My demos are mostly straightforward, but there is a lot of moving pieces, so you will see me like switching between projects and screens a lot. So I'm sure that all of you booked a flight at some point in time, at least pre-COVID-19. You will fill in a form on an airline website, pay with a credit card, and maybe minutes later, sometimes 10, 15, or 30 minutes, you will get your ticket in your email. Some of you ask, why this long time? A good airline booking system will basically be built to handle very high number of incoming booking requests. But how they do that without breaking the system? In most cases, this is a distributed system that has some messaging broker in between the services. You submit your booking request from a website. The request goes into a queue of some sort or similar structure, and then a backend service processes that item from the queue only if it has the bandwidth to do that. Now, if there are lots of items in that queue, that backend system will take time to go over all of them, and that's why the long time. Of course, if the airline company is willing to invest more or make things faster, they may spend more back-end systems to finish that queue faster. Like in real time, in real life, this is a very simplistic scenario, but like a really good distributed system will have much more brokers and services that all talk to each other. But this is again a very simplistic scenario. So in Service Bus or Azure Service Bus is one example of these messaging brokers that can sit in the middle between systems. Okay, so just to go, this presentation is not about Service Bus only because it requires actually its own presentation. But just to summarize what Azure Service Bus is, it's a messaging broker that is built to scale and to actually make your applications or separate applications resilient and scalable at the same time, beneficial for decoupling applications from each other. And again, as we mentioned before, it is great for microservices architecture, but it's not exclusive to them. So you can use it even with monolithic applications like CDS. And also another benefit is it allows you to connect on-premise systems, whether it's Dynamics or not, to cloud or outside services. Now to the inner workings of the Service Bus. Like Service Bus, you can do many things with it, with different contracts, we call it. We have relay, queues, and topics, and actually there is, under relay, there is one way, 2 ways, and endpoints. So Service Bus can act as a relay between your on-premise applications and service outside your network. This is not the same as giving that outside service a VPN access. Relaying using Service Bus does not require you actually to alter your network configurations. You can just specify an exact application endpoint living on your corporate network on a specific machine to be exposed to some other service outside your network. And Service Bus will take care of relaying things or relaying messages between your on-premise and the outside world. This is not in the scope of this project, of this presentation. Queues and topics are most common. Queues, as all of you know, are like first in, first out structures that can store messages to be processed when a receiver end is ready to process them. Topics, on the other hand, are publish subscribe structures, where the main difference between a queue and a topic is that a queue has a single receiver and a single sender and a single receiver, where a topic has a single sender and multiple receivers through what we call subscriptions. So there is a sender that sends to a topic. The topic will fan out these messages to multiple subscriptions, and each receiver is listening to a specific subscription. In my opinion, most of the time that there is a decision to be made between a queue and a topic, like a topic most of the time wins, because behind the scenes, actually Azure, they build topics based on multiple queues. So even though you have a single receiver now, it's not bad if you just create a topic and have a single subscription, because in the future, you don't know if another custom system will come and say, oh, I'm interested in that message as well. So you just need to spin off another subscription on that same topic. Normally, like a topic will broadcast the same message to all subscriptions unless you say, okay, I want a filter on this subscription with a specific condition that this subscription will receive specific messages and not other messages. The third thing that we will use here, the second thing is Azure Functions. Very popular, fast, scalable, cheap, and easy to set up. They are basically the new, from a CDS developer perspective, the new favorite plugin sister service. For example, I'm sure you always had to use some external DLLs and you merged them with plugins. Don't do that anymore because actually it's not supported, especially in the online world. Just use a function to extend the power of your plugins. It kind of removes so much limitations. As we saw in 2 or 3 sessions in this event, CDS has an out-of-the-box way of calling a function using webhooks. Now, actually, Azure Functions, the way we will use them here is different from what I just explained. That's just an introduction on functions. They have built-in triggers. One of these triggers is Azure Service Bus, whether it's queue or a topic, which we will be using here. Some may say that we do not use, like, why do we need to use functions in this case? Why not logic apps or flow? Because actually, if you go to Power Automate or logic apps, you will see actions saying, okay, when this happens in Service Bus, there is a trigger, sorry, in logic apps when a message is posted into a topic. Of course, you can do that, and based on my like I did some complex flows before, and actually if you try to build a complex flow or a logic app, it becomes as hard to read as a piece of code when it becomes like with so many blocks inside it with so if-else conditions and stuff. So it's not always actually the case that a logic app or a flow easier to maintain or read. Sometimes actually just writing code is the way to go. The third block that we will use here in this session is service endpoints along with Azure Aware plugins. So CDS has a no-code out-of-the-box way of posting data into Service Bus. We all know that sandboxed plugins, they have limited trust or sometimes no trust in the outside world, right? Services. But because it's out of the box, it's a feature by Microsoft, we can register what's called a service endpoint that has trust in Azure Service Bus, and it can communicate with Azure Service Bus. It is no code, but it is limited flexibility. You can't basically do anything with that posted message. Now, if you have more complex needs, you can develop a normal plugin and make it Azure aware. And actually that plugin will, behind the scenes, use a service endpoint to post the message, but at least you have a chance of modifying the message before it's being sent to the service bus. So I'm sure most of you at some point implemented a plugin or a workflow activity. And in both of these cases, there is this interface called execution context. Ivan touched base on this in his webhooks demo as well. So execution context is an interface that has lots of useful information. It's basically a bag of information that both plugins implemented as iPlugin execution context and workflow execution context also implemented in the workflow activities. What, like pre-entity images, post-entity images, input parameters, not very important for output parameters, but input parameters because there is a target entity inside where it has the fields. It's like a very important piece of information. Now, the Azure Aware plugin or custom workflow activity we saw before does one thing. It just posts the execution context to the service bus, whether it's a queue, topic, or relay. The receiving end will receive that execution context in an object called remote execution context. Both remote execution context and execution context are part of the same SDK. Now, remote execution context is not, it's actually the same as context, just a wrapper on top of it. There is extra, like few properties because Azure Service Bus actually adds some extra properties to it, but they're not important to our case here. For example, the Azure AD principal ID or something like that. We won't touch on it, but it's not actually 100% the same. There is a few extra properties here. Just like quick, just be careful when when you post the execution context, there is a size limit of 192 kilobytes for the single message. It's a whole lot of information. Actually, 192 kilobytes is a lot of information in a message, and most probably you will never exceed that. But what happens if you exceed the 192 kilobytes? CDS will start trimming that execution context and remove some properties from it. And actually, if even after trimming, it's still more than 192 kilobytes, the post will fail, which will lead us to think about maybe posting smaller messages or changing the design a little bit. Okay, so what are the scenarios that we will discuss today? The two scenarios basically here, they are very general, let's say. The first scenario is when other systems, like custom systems or non-custom systems, want to listen to CDS updates. I just call this here systems to CDS because I will be using this terminology in the service bus in a minute. The other scenario is actually the opposite way, where CDS wants to listen to other system updates, which I call CDS to systems. There is other scenarios. We will not go through them, but they are the same idea. Actually, they may fall under these scenarios, but they have special needs, like the on-premise Dynamics 365. Actually, what I'm going through today, 95% of it applies to the on-premise if you're still struggling with an on-premise system. Also, master data management between multiple CDS instances. Sometimes there is that instance that behaves as a master data instance, and other instances are listening to what's happening in data in that instance, plus that instance wants to send updates to, let's say, children instances. But in our case, we will just discuss the first two scenarios with examples. So the first scenario is we are going to tackle here is when CDS records, say an account, gets updated or created. Other systems want to know about these updates. Simply, we have some listener application of some sort, a custom application that is listening to Azure Service Bus in here, listening for changes. And a user, let's say, create a new account or updates an account. Then the Azure Aware plugin we will create, or the service endpoint, will post that context into Azure Service Bus, and basically it will be transferred into a subscription for that listener here. Listener is free to do whatever they want. Listeners are free to do whatever they want with the message they receive, but of course, maybe they have their own database that they want to update or something. Just to be a little bit more specific, what we're going to implement in here is, again, we have the CDS, and we will implement a topic. As we said before, topic, I prefer topics over queues because it's more future friendly, let's call it. And we have different custom applications. I've built one demo fake custom application that will be listening to a subscription and getting messages from the CDS. So let's jump to our first demo where we will implement this, and I'll just close the browser. Before I go to the demo, I want to just give an introduction of what's on the screen here. I have a CDS trial here, and I created an application registration because I will be calling this from a different tenant completely, which is a little bit more general case because it's not always in the same tenant where you are doing your integrations. So I have an app registration that has access to CRM. I have a client secret and ID that I will be using in an Azure functions later, right? So this is it about this side of this demo. I have a different tenant completely where I will do all of my Azure resources and service bus and functions and etc. Plus I have the plugin registration tool, which I just want to reload because I don't trust it has been idle for half an hour. Plus I have Visual Studio projects, just very quick overview. I have a .NET Standard common that has nothing in it except a couple of models. It's standard .NET Standard because I'm using it between .NET Core, .NET Framework, so it's better to be on the standard version for the common models. I have a fake custom sender. I call it fake custom ERP sender, and it's not an ERP at all. It's just a console application that reads some data from console, like read some option whether like I can create a fake account, fake contact, and that sender will send actually the information to service bus, and CDS will listen to it or will receive it. I have a fake website receiver, and call this maybe an HR system, I don't know, or an e-commerce system. It just will, this system, this custom system is interested in listening to what's happening in CDS. It's a .NET Core. I think this one is .NET Framework. I have an Azure function that we will discuss in the next demo, and the plugins, just normal Azure Aware plugin. So what we are going to do first is, because our first scenario is we want to send updates from CDS to other systems. I have created a service bus. Service bus creation is like very straightforward. Just give it a name, unique name, and a location. And currently this service bus has nothing in it. I'll just go into topics. I'll create a topic called CDS2 systems. And I will leave the default values. The messages will stay here for 14 days. Okay. Okay. So we have this. Now, as we said, the sender will send to the topic, but each receiver will need a subscription to listen to what's actually being sent to that topic. In my case here, I will create a subscription for that website that we just saw here, this e-commerce website that will receive notifications or receive messages from CDS. I will go and create a subscription, and I will just give it a max delivery count of 10. This is max delivery count is actually how many times a system can receive it, but not finish it. And after that, it will be dead lettered, or you can just basically deliver the game. So I created this subscription, and now we need a way for CDS to post information into this topic. Okay, so if we go to the plugin registration tool, there is what we call a service endpoint. And service endpoint is pretty straightforward. We provide the connection string of the topic, because again, we are sending to a topic, not to a specific subscription. And how do we do that? I normally like go into the service bus and create a shared access policy. In our case, we need just a send permission. We don't need manage send and listen, but for now, I will use whatever comes out of the box here. I will just copy this primary connection string, and I will paste it here. Okay. So I will say that this is a topic. As you can see, there is different contracts, queue, topic, one way, two way, and stuff. I will need a topic, and this topic is called CDS2 systems. Okay, and I'll just save. Now, actually, we don't need to do any plugins. If you don't have any needs to change the message before it's being sent to CRM, you just can come to this service endpoint that we just registered, and you can just register a new step like you do with a plugin, right? We can just say on a create of an account, just send the execution context to service bus. But in my case, I just want to show the plugin because it's the more flexible way of doing things. So I will leave this here. I will copy its ID because I will need it later, the service point and ID here. And I will open Visual Studio and show the plugin. So the plugin is 100% normal plugin, but with one difference. So that's not actually 100%. We pass the ID that I just copied into the configuration of the plugin or you can hard code it if you want. And all the boilerplate code, this is the same as you do with whatever other plugin or code activity. But the difference here is we instantiate, or we actually, from the factory, we get the iService endpoint notification service, and we get an instance of that. What we do is this cloud service will here post the context of the plugin into the service bus. But before that, we can change the context before we send it. One example I found here is, on update of let's say if you update an account and the name of the account, only the name will be inside the target input parameter, right? But what if I need more fields to be included, even if they don't change? Because in my case, my fake website receiver doesn't have actually an actual database. So if an account gets updated in CDS, I want all the information I need to create that account from scratch in my other database. So what I say here, okay, if it's an account and it's an update message, okay, go and find me that record that just got updated and find me the account number and name of that account, because I want to update the input parameters. Maybe this is not a great way of doing it, to update the target again with an updated entity, but it is, if this plugin is at the last stage, no other stage in the execution context will depend on it, that's fine, I guess. But another way of doing it is you can actually use the context.shared variables, which is a writable property. You can add shared variable as you want in here, and it will be part of the message, which is great because you can add data actually to the context. Anyway, so updated the context with more information, and I just post it here. I registered the plugin already, so I have this plugin here, and it has two steps: one on create of an account, and one on the update of an account. On create, the only thing we need, as you saw before, the ID of that service endpoint. Just pass it as a configuration. I will pass it in both, actually, the create and the update steps. Now we are ready. CDS, if everything is correct, when I go into an account and I update the name of an account, and I go to service bus to that specific topic that I just created, there is this preview explorer that we can use. And if you go to receive, I say I want this subscription. Okay. Okay, there is a message. This message actually is what it's triggered by our update to the account. If you just want to receive it, and you will see that it actually has the remote execution context here. Just I forgot one thing actually. So when you send, you have a message format. I chose the default now, the .NET binary, because actually I want to receive it as a remote execution context. But you can actually send it as JSON or XML if your other systems don't understand .NET binary. That's why you see all these weird characters. Anyway, so we have done the sending part. Now let's go to the receiving part. So my fake website receiver is a new .NET Core Razor pages, and I didn't change anything. It's just like whatever comes from scaffolding the default template. I just added, I created an interface called iServiceBus Listener, and I implement this interface, okay? And in the startup here, I register a singleton of this interface. I have also a fake database context that I use just to update some static lists so that we can see something on the screen. But it's just basically this. And this interface implements a single function that I configured at the end here, which is called register, handler, and listen. and start listening to service bus. So what happens here actually is I left everything except the pieces of code that will send and receive. That's basically just to show how easy things are here. So what we need to do first is, after getting all the dependencies and everything, we just need to initialize a subscription client. Subscriptions, again, are what they're responsible for listening to a topic endpoint. I have an iSubscription client, and this is based off in Microsoft.Azure.ServiceBus. And the only thing, not the only thing, but what we need to do here is we need to instantiate this with the connection string to the topic, okay, which I have stored in the config, and the topic name and the subname, which is a subscription name. Now, I don't have them, like I have, I think, in old values of things here. The same topic name I have the same subscription name, but because I created a new service bus, I will just go here and get that the connection string, basically, of that service bus. Okay, and I will paste it here. He should be good to go. CDS to website sub. So what if now we just run this website? Should, of course. I forgot this exception here. Basically, I just want to run to show you how it is now without anything coming from service bus. But let's implement it actually, and just because there is nothing special about the website, just a grid of accounts that I will show. So what I need to do here is I will start listening. I'll register a handler, okay? And this handler will require a message. Let's call it, it requires the function that will process the message, and it needs options. So options, basically, I will show you message handler options here. This takes an on error function that we will generate in a bit, and two required properties: autocomplete equal false. We don't want to autocomplete once something is read. We want to force the autocomplete ourselves, the completion ourselves. And I think the next one is maximum concurrent calls. I will leave it as 1 here. Now, this on error, I will generate it, and I will give the options to the registration function. Okay. So also process message, we will need to create it. I'll just name them here. So what we need here is just remove this, the on error, maybe just console.writeLine here. I'll just write the message, and because this is it has a return type of task, I'll just return task dot completed task. We are not interested in doing more things here. Okay, now in the process message, what do we want to do with the message that comes? As we said, we send it as .NET binary, right? So we can say switch here. What is the message? If you receive messages with different types, you can say, okay, get me the message content type. If the type is application JSON, then do something, right, with JSON. Again, XML same, but in our case, actually, it is application. This is a binary format content type of the one we sent, right? So what do we want to do here is we will basically just get the remote execution context, remote context, and we will just get it from the message. There is a handy function here called getBody, okay, and we'll tell it remote execution context. If you use JSON converters, it will face problems with converting to remote execution context here. You may need to use JObject if you are using JSON, I mean. So I got this. Let's say what is the entity included in that remote execution context is remote context.input parameters, exactly the same way you use it with a plugin. Okay. And after that, I have a fake helper message that says update database, because maybe I want to update the database of this website here. And after that, if things are good, I will just complete that message. Okay. Complete that just to tell the service bus that I read it, everything is fine. Of course, like if you handle error properly, not like me, in this case, you would put it in a proper try catch and everything. And here we need to make this async, because if there is a problem, you should not complete it async. You should keep it in the subscription, in the topic for another system to handle it, maybe, or you or this system when it's free to do so. Okay, so now we are good actually. We should be good. Update database, just to give you, it's just if it's an account, just update the account or update the contact. So let's start the application and see. Of course, because I don't have the same accounts currently in CDS in this database or fake database, only new updates or new accounts will take place. I don't have anything yet here, but let's say I updated, I updated this account. A message will go into service bus. This is listening to service bus. It will get the account here, okay? And if I go and create a new account, in a moment, I have like some, it's of course better to do it in Ajax or something to refresh this page, but I have kind of some time more to refresh it. Okay, so new accounts not working properly. Let's just check the create of an account. I have the new. Okay, it came now. Because again, messages are not exactly real time. They need some time to propagate, right? So actually now we finished scenario 1. We finished the case where CDS is sending updates to another custom system. Now let's quickly go to the presentation and see the scenario 2. We have systems. They are interested in, actually they are not interested in any other systems, but they just want relieve their responsibility and say, we have an update that happened in system 1. Just send it to service bus. If there is any other system listening here, okay, fine, which we have actually. We have CDS listening through an Azure function, because CDS doesn't have an out-of-the-box listener functionality. It has a sender functionality, as we saw, but not a listener functionality. That's actually why we are using the Azure function here. So this is basically it, right? So our second demo, we will basically go into Azure again. We will go to topics. We will create another topic we will call it systems to CDS. Any interested system, any system that's interested in sending updates sends to this topic, okay? And just give it a few seconds to build. Okay, systems to CDS. Again, CDS is now, from our point of view, CDS is just another listener, right? So we need a subscription for CDS. And I will call it here CDS subscription. Again, I will give it a max delivery count of 10. But actually, again, not CDS will be listening, and Azure function will be listening. And I will just create this subscription. Okay, so in our code here, we'll just stop this. I will show you first the fake sender. The fake sender is a normal console application will read some options whether I want to create a new account, just to simulate what's happening in that custom system. And after that, which I will hide because it's not of an interest. Then here, I will need to send that custom system. And because it looks like I didn't expect this to take a long time, I will just be pasting here. So we have the topic client is whatever we use to send a message to a topic. We just initialize it with a connection string and a topic name. And we build a message out of a model called fake ERP model, right? And that actually build message is pretty straightforward. We just, it needs a byte array of whatever you're sending. So first let's call this here. So we get the model, make it into JSON and convert it to bytes and build a message out of it, return it and send it to topic client, then close the client when you're done. That's it. So this is actually the piece of code that you need to send information to a topic, right? Now, as we said, like CDS doesn't listen, so we need a function to listen. Okay, so we have an Azure function. Just this is exactly out of the box. I just added a couple of helper methods to update an account, upsert an account, or upsert a contact in CDS. Now, how do we do this? Is I'm using version 3 functions, and because I wanted to use version 1, but some messages actually I got lost with me, and I don't know why. I read that there's issues with version 1, and actually there are issues with version 3 as well. But version 3 using the pre-release alpha version of Power Platform.cds client worked fine. CDS service client is actually the same as CRM service client with very few modifications. The same way, you can create a client like this. And in my case, because as you remember, my CRM lives on a totally different tenant. That's why I created the app registration there. So this is the client ID and secret of that registration. I create the client, and in here, what I will say, I will just instantiate that an instance of that client, and if it's ready, I will receive that message that I just sent from the fake sender, deserialize it into that fake ERP model that we put in common. And yeah, it's not a good thing, but I have both in actually a single type, but we should have a fake ERP contact, fake ERP account model, but just for simplicity here, I have them in one class. Oh, if it's an account, update the account. If it's a contact, update the contact, okay? Last thing we need to do is we need to point the sender function to the proper topic, because currently I have the connection string and topic name as empty. Topic name is easy. It's called systems to CDS. But for the connection string, we will use the same connection string because this is a connection string for the service bus. It's the same between all of them, right? And now we should be good. Okay, the function is ready to listen, and the sender should be ready to send. Okay, and let's see. So I'll now just run a local instance of the function here, because as you know, we can run it locally. And it will connect actually to the topic in Azure, right? So we have the function here, and I will spin off a sender instance. Another screen. So this sender says, okay, so let's try and simulate creating a new account in the ERP system. I'll just put one. Should have better messaging, but hopefully this created a new account here. Let's see. Just maybe before that, I will. actually it is. Let's just look at the sender again. And just see if there is any exception. Okay. Let's look at Azure and see. Using this preview feature is actually really cool because you can debug things without depending on the systems themselves. So systems to CDS, and we have message count of 2. So this means that our function is not listening actually. So it is being sent to CDS to service bus, but the function is not listening. Let's see why. Okay, let's close this. I don't know if I updated the. Oh yeah. Systems to CDS connect. Okay, I have to update the connection string for the function. I'm using an old one. Okay, that is it. Hopefully. So I'll just get the same connection string to the function. And start it again. We just simulated if CDS is down, right? Because CDS was down, or function was down because it wasn't listening, but the message was still in the. Oh, we got them here. So the messages were still living. They will live for 14 days in the topic, right? And now we have 2 new accounts created because when the Azure function decided to go up again or to go online again, it just processed those messages, and that's the beauty of not caring about a system, not caring about other systems, right? Or what they are doing. So here, if we open our the fake receiver, the fake website receiver, and we try to create we try to simulate another sender now. So let's say that I want to create this, remove these guys here. So this will send a message. Azure function will create it in CDS, but also because we have another listener, because we just created an account in CDS, and there is people who are listening, right? There is systems who are listening to those new accounts. So that's how everything works together, right? There is a listener on the far end of a different topic, but because our plugin here posts to that topic, those listeners are able to receive it. And if we discussed the new accounts here, and we discussed, I don't know if it's just try to change an account, Let's say if we change this account, just remove the word account here, and we should have in a few seconds this change directly here. Okay, that is the second scenario. Back to the presentation quickly. Just I have a couple notes here. Oh, just one thing I didn't show is the Azure function. I'm sure most of you know this, but other than providing the name, you just say what kind of trigger, as we discussed in the slide before. I want a service bus trigger listening on this specific topic, on this specific subscription, with a connection string that is stored in this setting, which we saw here, okay? One more thing, if you want to publish this function to Azure, which is just right-click and publish, this local settings JSON, your Azure function won't have this settings, so you need to go to your Azure function, add a configuration setting, an app setting with this, because this is just for local, right? There, it won't work until you add that setting with this value, and you can make it part of a DevOps pipeline or something. Now, I'll go back to the presentation. I added this slide half an hour ago before the presentation because I heard it in the webhawks session, yes, there is some promising DevOps tools that you can integrate with Azure DevOps. The one by Wael Hamza, I guess, where you can update steps. If you don't want to use that and you're good at scripting, you can just, like, at the end, everything is in in an XML format in the solution, even though it's not like really maybe recommended. Maybe you can change XML if you are moving between dev and UAT and production, excuse me. You can change those endpoints where you are pointing your CDS to which topic or service bus. That's in case you have different service bus for different environments like dev and UAT and production. There is, of course, always the manual option, which is in CRM projects or CDS projects, there is always this document of post-deployment steps that you need to do. Just make this as one of them. Plus, you can use the same topic for all environments, yeah, but use different subscription for like a dev subscription and a prod and UAT subscription, right? And that actually is easy because the subscription name where you listen to is part of your custom code, like the Azure function we just saw, which you can make it as an environment variable where you can change between environments. Error handling is basically, we registered the plugin, the Azure Aware plugin, as asynchronous, and that's important because synchronous will work. In any case, the endpoint will be asynchronous always, but the plugin itself, you can either register it as synchronous or asynchronous. Now, why we recommend asynchronous is because a system job will trigger for asynchronous plugin steps, and if, God forbid, service bus is down, then that system job will retry for you for a few times until it fails, which is something that you can get just directly if you just use it as asynchronous, right? Also, messages that get sent to service bus, but they are maybe more than 14 days and no system listened to them, they will move to another queue called, or topic called dead letter queue, right? And you can, as an Azure administrator, you can set up alerts to when messages get dead lettered so that you know that your systems are not doing great. And that's it. Thank you so much. Any questions, please?
I'm not seeing any questions. So guys, if you have any questions, oh yeah, there is one. Why not use a post image was one of the questions from Tex.
Why not use a post? Now, if on the step we created images here, they will be part of the context, part of the data, but it depends. Why do we need the post image here? The execution context at that time will have the information. At least in my demo, I needed the information I need. I have the information I need, but if I need like to know exactly what happened before and after, yes, maybe I can register pre or post images.
Yeah. Are there any other questions? All the positive feedback, Omar. Thank you, and thank you for having this session and then sharing your knowledge with us today. Oh, there's one more question. Sorry, Omar. Will source code for listener be available? So yeah, someone is asking for the source code. So is there any GitHub site?
I don't have it yet, but I will upload it on my like I have a GitHub. If you can access it, it will be there in a few minutes after this presentation.
All right. Could you share a GitHub link, Omar?
Sure. Yes.
You can just paste it in the chat window.
Yeah.
All right. Thank you, Omar.
Thank you.
And okay, so now we have very exciting prizes to give.